So let's start right now. Okay, before I start, just brief introduction. My name is Cha. I'm a solution consultant for media and entertainment from Tech Solutions, a Autodesk distributor. So today I will cover part of this simulation sharing session. So just treat this like a sharing session. It's very light atmosphere. So if you have any question that you want to ask during our sharing session, you can just type in the chat room or in the Q&A box. Okay, then we will gather all of the questions, then we will answer it in the end of the session. Okay, so let me just continue. Safe harbor statements. So I will be making some forward-looking statements. And these statements should not affect your purchasing decisions in the future. So this is the agenda for my part. This is my agenda. So today I'll be talking about fluids. This tool set in 3ds Max. So I'll cover the brief workflow on how you can create fluids in simulation in 3ds Max, things like that. Okay, so today's session is more on the high level product demonstration. So we'll skim through a lot of the buttons, the parameter, the functionality, the tools there, because we don't have enough time to show all of it in 1 hour. So it's not like a deep dive, step-by-step, pure tutorial or training session. So be mindful of that. Right, okay. So let's continue. What is fluids? So if you see on the screen, top right corner, you will see this is the effect that you can achieve in 3ds Max if you use the fluids toolset. So these are the presets that is available in 3ds Max. So you just need a few clicks, then you can just access to those fluid simulation. A lot of it like ketchup, honey, and if you want to have some kind of toothpaste kind of texture, fluid simulation, you have it in 3ds Max as well. So the function of fluid is to simulate physical properties like water, oil, honey, and lava, as well as replicate the effects of gravity, collisions with objects, and also you can add disruption by using the motion fields in 3ds Max. So in the bottom right corner, you will see this is the one of the YouTuber. He's showing how you can incorporate the motion field in the fluid simulation. Okay, so you might be asking like, right now we have 3ds Max 2022, but if I only have like an older version of 3ds Max, can I use fluids? Can I do like a fluid simulation? Yes, it goes back as early as 2018.3. So if you have a version that is 2018.3, you can just open it out and then try it out. Okay, and but it is recommended that you use a newer version because there's always a update to improve the user experience in the fluid simulation. All right, so enough of me babbling around. So let's see how you can create fluids in 3ds Max. Okay, so we have a simple scene. I just create like a ball and then a ground and then have liquid to interact with it. So if you guys ever heard about Bifrost, the liquid solver, I mean the simulation, the technology that is used in 3ds Max to simulate fluid is the same as the Bifrost simulation in Maya. So if you ever have experience in Bifrost or you want to expand your knowledge like using this fluid simulation in Maya, you can take whatever that you learned today and then apply it in Maya because it is the same thing. It's just that one is called Bifrost in Maya, another one is called fluid in 3ds Max. Basically, they are the same thing. Okay, let's start. So let's start by create a box. So this box will be interact with the liquid, and also let's create a sphere here as well. Make sure the plane have a thickness when you want it to be interact with the liquid. I will center it as well. And right now, let me go over to fluids, liquid. So it doesn't matter how you rotate it, because the water will still fall down. So right now I'm just rotating it so that just give me an indication that I know that the water is falling down. The liquid, let's go over to the modify panel, and in the radius here, if you increase the radius, this will increase the origin of the liquid. So the icon size doesn't make any difference for the emitters, only the radius will have the effect. So let me just change this one to maybe 0.8 like this. So let's open up simulation view. Let's keep everything as it is. And right now, I don't want to simulate the whole time frame here. So let me go over to the time configuration, change the end time to 17. So I will only simulate 17 frames. Okay, and let's simulate. This is the default parameter. I did not change anything. So right now you see the liquid is falling down. But if you notice that actually the liquid is going straight through the model. So we don't want that. Let me stop this one. Right click and clear the cache. Let's start all over again. So let me change this color to maybe this color, and we'll have these two as the collider. So let's go over to the liquid attribute again, pick this one, and deselect pick. So let's try one more time. Depending on your scene, if you have a heavy scene or if you have a big environment, it will take more time to calculate, to simulate. So when the simulation done, you will see a tick over here. It's a really small blue tick over here. It means that the simulation is done. So right now, let's try to render it, see how we actually looking at. We'll use a real-time viewport here. Let's try it out. So right now, you don't see anything right here because we are still looking it as a, if I turn over to display setting, we are seeing it as point. So right now, let me just change this one to normal again. Select this one. So let me change this to Bifrost cache mesh. But right now we don't have a cache mesh because we did not have generate the mesh component. So the cache here is empty. Hence there's no cache mesh here. Empty. And as you can see here, we have the Bifrost cache mesh listed down over here because the liquids, the fluids in 3ds Max is the same algorithm as Bifrost in Maya. So if you have used Bifrost before in Maya, it will be the same workflow, almost the same concept and workflow. So right now, let me change this back to point. And let's turn on this one and do a simulation one more time. So now the simulation is done. The solver has done solving, and you will see that this create mesh component here has the blue tick. And let's change this one to Bifrost cache mesh. Let's try to do one more time the render using a real-time viewport active shape standard. So let's apply a shader to it, an Arnold shader. Let's press M to bring out the material editor. And I will use the glass surface standard surface, because this one will have the similar outcome as water. And let me create a light in here. Select the light. Change from quad to sky dome. And in the texture, let me use the built-in HDRI environment here, where I can select a pre-built-in HDRI. So I'll use this winter leg, open it. Let me select this one again. Increase the exposure. So this is basically how it worked. Okay, so just now was a pre-recorded video that I did, because simulation actually for the 17 frame of simulation, I took like around 2 to, I think it's within 5 minutes to finish it. So I couldn't do it in real time. So yeah, next up is that one is the basic one. So let's go for another version which is a little bit deeper than that. A little bit more, just now we have a collider. Right now we want to add in like a motion field to have some turbulence to the liquid. Add kill planes. So kill planes is like a plane that kill off any particle when the particle hits on it. Then after that, it's the same procedure as just now. You are done with the simulation, create the meshing already, the solid meshing, then you can just select the meshing, assign it with the Arnold standard surface preset, and then render it real time with active shade. Yeah, so this one will took less than I think 5 minutes video. This is the workflow of creating the simulation. So right now, let's try to add in a little bit more things here. We have the add collider. Let's explore the kill planes and also the motion fields. So the function of kill planes is that, as you can see, the water, after the water get through this interact with the collider here, it will continue falling and falling and falling. And if you don't want that, we want to create like a kill plane to tell the liquid, the fluid, like if the liquid cross that threshold, it will be killed off. So let's just create a plane. So it doesn't matter how big it is, as long as the water, the liquid, the fluid. Okay, so basically the kill plane is just to tell the liquid to, okay, just stop simulating after you hit my plane. That's it. So this kill plane doesn't need to be rendered out. So that is why I'll go over to the object properties and turn on the see-through and that bounding box stuff. So yeah, and we'll add this plane as a kill plane. Yeah, so this is like an indicator, like a dummy for the liquid to know, okay, if you hit on this plane, it will be killed off. Then right now I'm adding the motion fields. So it's over at the icon here, motion fields. Let me just fast forward to a little bit at the back. Magnitude is like the intensity of the motion field. So right now I increase this one to 10. As you can see in the display here, I turn off velocity grid. You then, once you have turned on this one, you will know that, oh, okay, the wind is actually blowing from left to right. Okay, so that one is just for display only. It doesn't really change the magnitude or the intensity or the density or the direction of the motion field, the wind. So right now I'm clearing off the cache that I have just calculated just now, because if you added in new things like kill planes or the motion fields into the liquid attributes here, you will have to recalculate it. You have to let the fluids to recalculate whatever that you have put in here. So just hit start solve to solve it. So this is the outcome, because we have the wind blowing from left to right, and that is why the water is like splashing to the right side. Okay, so once this one is done, okay, there is a thing that might be a bit confusing. That is a display setting here where I change from point to Bifrost cache mesh. Why I need to do this is because if you want to assign your own material to it, you will have to have this Bifrost cache mesh available. How to make it available is to use this create mesh here in order for fluid to calculate it and then show it over here. Only then you change the display type to cache mesh, then you only then you can assign the material that you want. So the rest of it is almost the same thing. And this one, I don't want it to be rendered out, so I forgot to turn off the renderable button at the rendering control. So right now the kill plane is acting as a kill plane, but it is not showing in the render. So in this case, if you want to yeah, here is another thing is there's a base voxel size, which is quite important, but this one may takes up quite a lot of time, so I just skip it. So when you want to have like a more accurate simulation of liquid, you actually have to decrease it. By default, this one is 0.5, meaning the voxel size is 0.5. If you decrease it, it will be like 0.2, then the size of it will be 0.2. So right now you can see that the water is actually a bit blobby, like a very big chunk of liquid droplets. So if you want like the thinner, smaller particles, water droplets here, then you will have to decrease it. But the downside is, I mean, it's not like a downside. If you decrease the base voxel size, it will increase the realism because the water is not big droplet. It should be smaller. But if you increase this one, it means that it will take more time to calculate it. So the simulation time will be longer. So this one you will have to use at your own risk. Oops, let me go back here one more time. And basically the same thing, yeah, just the simulation parameter and the liquid parameter that you might want to pay attention to. Yeah, so another one. This is the last one. I promise this is the last one for my side. Okay, we'll use a preset from library. So let me just play this one too. Turn off my voice. Okay, so right now everything as clean scene. We have not started solving anything yet, but I just want to show you that if you want to have your own liquid, like you want to have like a presets, right? If you remember the first slide that I'm showing, that you can create like a toothpaste kind of material or the honey kind of material, you can use it over here. This is the liquid parameter presets. You can change this one to honey, and then the liquid that is falling down from this round sphere emitter, it will become it will act like a honey kind of texture. So just load it up and then do the same thing, run through the solver. Right now, this is acting like honey, very sticky kind of looking. Yeah. So what you can do is, I mean, you have these presets, right? You just load these presets up. And if you want it to be a little bit stickier, it's okay. You just go over to the viscosity, increase this one to make it a little bit more sticky. Yeah, so you can just use the preset like a head start for you to do more modification on how you want your liquid to look like. It's over at the solver parameter, liquid parameter, and presets. Okay, so you can change to other thing also like toothpaste kind of looking. And of course, we'll need the Bifrost cache mesh. And over here, you see, I already have the honey standard surface available in my slate material editor. So this one is actually the Arnold built-in. It's not built in, you have to download it somewhere from the Autodesk store. It's free one. You have 3ds Max, you can just download it for free. Just have to sign in and then download it there, install it in 3ds Max. So after you have chosen the honey presets liquid, then just go over to select material and assign the honey standard over here. And immediately you will have a liquid acting like a honey and looking like a honey. That's it. So yeah, this is the pointer, a small pointer for you guys. Since this one is a simulation, right? You have to make sure that your cache is set to a disk that is larger. Because for my side, this small 17 frames, I took like a 1 gig of cache. So yeah, you will have to write in your disk, so you make sure that you have just locate your project to the disk that is larger. Don't put it at C if your C is already showing red bar. Okay, and also for the better accuracy, reduce the base voxel size. Yeah, but it will increase the simulation time. So be careful on that. Solver, the liquid solver will use all the CPU cores. So I have, if I remember correctly, I have 12 CPU cores, hence it's moving a little bit faster. So more CPU, of course, the better. And also have a decent RAM to help simulation and playback speed. Because when you are simulating your liquid, it will use the RAM in the 3ds Max. Actually, you can set it over here. Just quickly show you. Right now in my caching, I have 8 gig set for my display cache. Okay, so you can increase it up to like 16 because I have 32 gig of RAM, so I can increase it. But be careful lah. You don't want to use it all unless you are just going to maybe just focus on the simulation stuff and you're not going to do anything while you're simulating. So be careful on that. By default, it is set to add. Yep, that is on my side. That is all on my side. So I will pass the floor quickly to S1 to continue on his sharing on dynamics. Let me just stop share.
All right. All right. Thank you, Cha. So let me share my screen first. Everyone can hear my voice, right?
Yes, loud and clear.
Good. So my name is Izwan. So I'm the application engineer from Progressive Computer System. So just now Ms. Cha already covered on the liquid. So for my part, I'll be covering something more solid, more of a solid object instead. So let's on. Right. So MassFX is basically a tool set for adding realistic animation into your scene. So if you could imagine the animation for a balls dropping down the floor, or a bowling or a bowling ball hitting the pins, right? Even this simple animation is actually, if we do it manually by keyframe, it it is a, a lot of tasks. So by using this MassFX simulation, we just need to set up just a few things, and the MassFX simulation engine will do the rest of it. So for MassFX, obviously it it has benefits to those visual effects artists, but it also actually indirectly have some benefits for the modeling part, especially if you are in interior design. So for example, if you want to model a curtain being blown by the wind, right? So I will show that later on, how you will do that to give your scene a more natural, a more organic scene that is more that is more interesting lah to the eye. So basically MassFX uses a few elements, or I would say modifiers. So the first one is rigid bodies. Rigid bodies is actually basically those objects that do not change shape. So as you can see in this video here, all of this is actually rigid bodies. So it is divided into three types. So we have dynamic, kinematic, and also static. I will explain this on my next slides, what they are and how they affect the simulation in MassFX. And then we also have mCloth modifier, which allow cloth object to be included in the simulation and to react to the object inside of MassFX. The next one we have constraints. Constraint, you could imagine it like a joint. It's basically a link between two rigid bodies, or a single rigid body anchored to a global space. So you could imagine like this chain link, or you could imagine it like a door hinge, or something like that. So I will also show this one, how to do a simple setup later on. And the last one is the ragdolls. So basically you can allow your rig and animated character that you have model to be included in this simulation. So for moving on, right? So in this video, I will show you how to bring out the MassFX utility tools, right? So first you go to animation and you go to MassFX, you go to utilities and show MassFX tool. It will bring up this toolbar, right? In this toolbar, there are a few panels. So the first panel is the world parameters. So basically you have the gravity settings here and the ground collision. So basically right now this scene have this gravity setting as what it is in our real world. So so, and then this ground collision, if I turn this on, this object would be fixated on this invisible plane. If not, if I turn this off, because of the gravity, all of this object will fall down, right? So and then we also have setting for the rigid bodies. And for the next panel is the simulation tool. We have the playback option to start the simulation, to reset the simulation, and also making of the simulation into our keyframe animation here. Later on, when we already have our simulation and we want to browse through the simulation, what we can do is we can bake it first into our keyframe and we can browse it later on. So and then here is this multi-object editor. Since I haven't created any object for the MassFX yet, but here it will show basically the physical properties of that object, which you which you could change the mass, the density, all the physical properties that would affect the simulation as well. And the last thing is the display option. This is also a global setting, whether you want to show the mesh of the MassFX object, right? So for the rigid bodies simulation setting, for the setup, as I mentioned earlier, we have three types of rigid bodies. So the first one just now is dynamic. So basically, dynamic is object that that is affected by the gravity that we set here, and also affected by force spacewalk. For example, wind, directional gravity, or uh, or P-bomb, right? So dynamic object is those that can be affected by all of this thing, even with other objects that struck its object. So meaning if I have another object that hit this dynamic object, it will react to that collision, right? So for the dynamic one, we'll set it to this series of blocks. Then the next one we have kinematic, right? Kinematic is basically object that have an effect on dynamic object, but don't have but is not affected by the other object. So basically, I will set this one to this ball, since this sphere is the one that will hit this pile of blocks, this pile of dominoes, right? So I will set that as the kinematic. And last is the static. Static, as the name shows, is basically is not affected by the rest of the object, but it would affect the other object, right? So if, for example, if I turn off this ground collision, if I don't have this plane, this green plane, or this dynamic object would of course would fall down because of the gravity. But once I set this, so this block of object will stay on the plane that I've just created. So moving on to the setup, let me
Oh, so maybe can think like this. Is it like kinematic is like a driver, then the dynamic is the one that is reacting to the driver lah, but you
yes,
still
yes,
need like a static to hold them.
yes, yeah,
Okay,
something like
okay,
that,
okay.
correct.
Understand.
So how to set up those objects that we want as either dynamic or what. So we go to the animation just now. Sorry. Okay, we go to animation, we go to MassFX, and we set as dynamic or static or kinematic object. Only that for kinematic object, this sphere right here, we have to animate it first to to animate the motion that is like it's hitting the hitting this box, right? So we have to animate it first. So I have animated here in 30 frames. So once I have animated that, and then we can run the simulation. We go to the simulation tools. Yep, sorry. Yeah. When we play it, yep, it will show as it hitting the blocks, so it will have an effect on the rest of the dynamic objects. So right now, since we have set the gravity setting to as the real one, the block all falls on the ground. So but what if we set it to no gravity, right? So all the dynamic objects that is hit, that is struck by the other object, will be floating because there is no gravity that was set on the world parameters, right? And then sometimes you might encounter in your simulation there is something weird about your simulation. Sometimes if this kinematic object does not collide with this dynamic object because this one is moving too fast. So in those cases, you might want to check on your frame rate and your substep. So in case you encounter those situation where the ball just pass through this dynamic object instead of colliding with it, you might have to increase this substep. So this substep is basically an additional calculation for the simulation. So if I set it to 0, basically if my frame rate is 30 FPS, right? Frame rate per second. So basically it will just do 30 calculation. So one calculation for every frame, right? So the next thing that I want to show, right, is in the multi-object editor here. Yeah, multi-object editor. So here you will be able to change the physical properties of each of the object. So I will be able to change this pile of boxes as concrete, this one as steel, and they would react differently in the simulation because they already have a different mass and also a different density, right? Okay, so that's pretty much it for this rigid bodies. So let's move on to the next one. All right, so for the M cloth, so basically what this one does is that it allows you to bring cloth object into this MassFX simulation. So you actually can also use this simulation for your modeling work. So for example, in interior design, right, you might have in your scene, you might have a window or a door that have a curtain over it, right? So instead of you want to render your scene with this boring looking curtain just sitting there, right, you might want to have it like it's being blown by some wind, so it will give you a more natural look. So in order to do that, you can run the simulation in MassFX. So basically what you have to do, you have to set this cloth as M cloth. So what you have to do is go to animation, go to MassFX, and you go to cloth and you create M cloth. So right now this cloth is already is supposed to behave already like a cloth. So if I run a simulation, if I play the simulation now, it would behave like a cloth should. So when it drop down into this floor, you see, so it will be folded like a cloth should be. So right, just now since it's not attached to any of these objects I have set here, so I will attach the cloth by its notes by its knots to the rail here, so that it won't fall down. So I will fast forward on this one. So this one is more on the modeling. Okay. Okay. So once I have set that, if I run the simulation, you can see now it no longer falls down, but you can see the movement of the cloth right now. So, but this is not enough for me. I want it to be blown by some wind to get a more interesting curtain in my scene. So I will need to add some force space warp. So I'll be adding a wind. A wind here. I will create a wind that will blow from this direction here on the left side. So this just to create a wind.
Create some ghost wind.
Yeah, create some ghost wind. Don't know.
Wind coming out of nowhere.
Yeah, out of nowhere. So before I run the simulation, there is a few settings for mCloth that I want to share. So here, if you can see, for cloth behavior, we have actually dynamic and also kinematic. So similar to rigid bodies, dynamic is the one that can be affected by pretty much everything. Kinematic is the one that is affecting the dynamic cloth lah. So over here you have the bake, right? If you see here, so when you run the simulation, you can bake the simulation to the keyframe here, just for this cloth here. So when you bake it, so you'll be able to browse through all the keyframes throughout the simulation lah. Then you have the live drag here. You'll be able to drag the cloth directly from here to see how it would react, right? So then the next one, just now, see, I already have added the wind force. I have to add it in the forces here, so that the cloth would react to the wind. If not, it won't react to anything. And you can also set the physical properties for this fabric. So you can change the density, the stretchiness, the and other properties, even self pollution, tearing also got meaning uh, a silk and different jersey cloth being blown by the wind, it would have a different kind of looks lah. So this is where these physical properties comes in. So you'll be able to change that. Then now when I run the simulation, I already have my wind. When I run my simulation, yeah, the wind is blowing, but it's blowing past my doors, right? So I would need to set these doors and this wall as static rigid bodies, as what I have shown in my previous slides, so that the cloth won't pass through these walls and door. Right. So once I have set that, it will look something like this. Yeah. So let me change the wind direction a bit more to the left. Right. So now I already have the desired effect that I want, and I want to bake this one into my keyframe, so that when I want to choose the frame to render, I can choose directly from here lah, from keyframe. So once I have baked, I will be able to browse through my keyframe and choose whichever scenes that I want. So just now I've shown you this bake option for individual cloth, right? So here you'll be able to bake all. So in your scene, you might have multiple cloth, right? Multiple door, you might have multiple curtains. So if if you want to simulate everything in your scene, you can use this bake all, so that you'll be able to browse through whatever curtains that you have in your scene through here. But if you only just want to bake just for that cloth individually, you can bake it from this here, right? Okay, so that one for cloth.
Yeah. I think it's really good. I mean, like, because for architecture visualization, like if you have like a wind blowing through the curtain, or it looks, the whole image looks a bit more like there's a people living there lah.
Yeah. All right, so for the next one, the constraints. Constraint is basically previously I mentioned, it's like a joint. It's like something that is restricting and link two rigid bodies together, and also it's also possible for one rigid bodies to be anchored or attached to a global space lah. It's like in the air, you can attach that rigid bodies to the air, something like that. So just now I've shown this is like a gate just now in this video. So it's being blown by the wind I've created here. So in this gate I have set a constraint hinge constraint for each of these gates gates object. So how to set that, let me show you here. So once you have model your gate, right? So this one I'm just creating a dummy one only lah. So just for this demo purposes. So before you add the constraint, you have to make sure the object that you want to place this constraint, the pivot for the object has been moved to where the constraint would be at. So for this one hinge, since this is a hinge constraint, since I want this to move like this one, right? So I have to move the pivot here instead. So I just choose this object and then create this hinge constraint. So right now, my hinge constraint allows this object to move to rotate in this degree. This white color lah is should be 100 degrees. So but I want it to be just a 45 degrees. I want to restrict it the movement to 45 degrees, so I can change it from here. If you go to the swing setting for the z-axis, yeah, you will be able to change it from here. So let me fast forward. So now I have set it to 45 degree, and I just want to make it open outside right here. So I've rotate the constraint to be on the outer gate, right? Okay, so we also need to set this column where we'll set this as a parent to this child object. So I have to set it as static rigid bodies. So in constraint, you have this parent to child relationship. So parent to child relationship is basically this child, right, would be affected. This is child, this is the parent. So the movement of the parents will be would affect the child as well. So right now I'm making this parent one, this one parent 2, and this child 1 child 2, sorry. So any movement from here would affect this one as well later on. So okay, let me play. So where you can set it, the child and parents is from here. So you just click on this and you just click on the which object you want it to be, the parents or the child. Okay, so the movement will be restricted by its parents. So let me set another one for the second one as well. Same thing, right? So once I have this one, I will add the forces, the force space warp. I will add the wind. You have to make sure that this ground collision is off. If not, this gate will be fixated into the plane. So when I run the simulation, yeah, it would affect. And before that, you have to add this wind into the forces for these dynamic objects as well. If not, it will be affected by this wind. Right. So that is one of the example for constraints. Right. So the last one, right? Okay. So for ragdolls, let me clear this one. Okay. Right. So for ragdoll, basically I want to ragdoll is basically I want to bring my animated character, my rig character into MassFX simulation, right? I, I want it to be affected by other objects in my MassFX simulation. So basically, I will be first thing that we have to do. Of course, we have to rig our characters. I will just fast forward this one since this is just more on the rigging. Once we have put the once we have linked the skin to the bones that we have created, right? We need to create the ragdolls. So the way that we can create that one is to select the first bones that you have created, and you go to the animation. Let me fast forward this one. Yeah, where is it? Okay, so since I have created mine, this one display as grade here, but once you have if you haven't created your ragdoll, so you have to go to MassFX, rigid bodies, and create dynamic ragdoll. So what it does is this ragdoll will create its own mesh over the bones, but you still have to link the bones to that ragdoll mesh. If not, if you run the simulation, nothing would happen to it. So once you have linked all the bones to the ragdoll mesh, as you can see here, right? Yeah. Okay. So when you run the simulation, it will be affected by whatever the force that force or dynamic or kinematic object that we have created in our simulation. So this guy was flying around just now because of the bomb that I've created before here. So as you can see, the body is not separated because the bones itself, the intersecting bones itself is also a type of constraint. So it won't be able to, I would say, be separated lah. Yeah. So if you think your models when during the simulation is like it being squish, right, is a bit weird, you can rescale the envelope size of your character. So you have to rescale it to to uh, to maximize the amount of skin that it will affect lah. So the bigger this range, the the closer it will be to the skin that you have created. So your character in the simulation will not be squished lah. All right, so that's pretty much it for my part.